Okay, Stats and Mechanics Year 1, Chapter 11, Question 11. Particle P moves along a straight line. Initially, P is at rest at point 0. So velocity at P is equal to 0 meters a second. Okay, at time equals 0. At time t seconds where the acceleration of P is proportional. Watch out for the proportional. Okay. To 7 minus t squared, and the displacement of P from O is s meters. When t is equal to 3, the velocity equals 6 meters a second. So when t equals 3, velocity equals 6 meters a second. So let's first look at this acceleration is proportional to 7 minus t squared. If we want to show this, that s, so I think if we do the velocity is equal to the integral of the acceleration, okay, which will be the integral of, now this is going to be acceleration equals k times 7 minus t squared. So we can put that in, k 7 minus t squared. I wrote that wrong, didn't I, up there? Okay, we can then start taking that out and hopefully find everything that we need. So we've got velocity equals k times 7t minus t cubed over 3 plus c equals velocity. Now then, I know I've got two different equations here. I've got velocity equals 0 when t equals 0, and I've got velocity equals 6 when t equals 3. So if I put those into here, then I can write out, let's do this one on the left first, 0 equals k times 7 times 0 plus 0 cubed over 3 plus c. So I've got 0 equals kc, and over here, doing the 6 and the t, I can say 6 equals k times 7 times 3 minus 3 cubed over 3 plus c. 6 equals k times 12, because that's 21, that's 9, plus c. And so I can say that 6 equals 12k plus kc. Okay. Can I solve those two things? I think I can. Since I know that kc equals 0, I can say 6 equals 12k plus 0. And so 6 over 12, which is equal to a half, is equal to k. So that brings me down to my original velocity equation now. Oh, I haven't found c yet, have I? So now that I know that that is 0, well, I know that that's to make it equal to 0, so with that in mind, I can put in 0 equals a half c, so c equals 0. All right, so coming back up here, I can take velocity equals k. Velocity equals k, which is a half times 7t minus t cubed over 3 plus 0, so that's gone. Now I can say that my distance is equal to my integral of velocity by time, which means I'm looking at I'm going to step the half out straight away, integral of 7t minus t cubed over 3 dt, and that's going to give me a half times 7t squared over 2 minus t to the 4 over 3 times 4 is 12 plus c, and that's equal to my distance. I know that my distance was equal to 0 when time was equal to 0. So if I put all of that in, I can say that 0 equals a half times 0 minus 0 plus c. So c is equal to 0. So my distance is this one. Distance is equal to a half 7t squared over 2 minus t to the 4 over 12. Not quite what I want, but somewhere close. Okay, let's bring this up to make it into, if I was to have all of that as halves. Right, let's multiply, let's factor out a t squared, so a half t squared is equal to 7, no, not equal to, is equal to 7 over 2 minus t squared over 12. Let's make this into times by 6 times by 6. That makes 42. 42 over 12 minus t squared over 12 means I can take the 12th out on the next step, making that half a 24. Okay, so s equals 1 over 24 t squared 42 minus t squared. Okay, which is the requirement for the show.